Electrician program. Number 8. Overcurrent protection. Chapter 8. Objectives. Explain the causes of overcurrent. List and describe electrical circuit overcurrent protective devices, or OCPDs. Discuss the rating systems for OCPD. Some of the technical terms described are circuit breaker, circuit limiting fuse, dual element fuse, ground fault, interrupting rating, overcurrent protection device, overload, potential difference, short circuit, single element fuse, time delay fuse. All electrical circuits must have a overcurrent protection device installed. An overcurrent protection device, or OCPD, shuts off power to a circuit when the current in that circuit exceeds the ampacity rating of the OCPD. Causes of overcurrent. The overcurrent may be a result of overload, short circuit, or ground fault. Any of these conditions, if left unchecked, could cause a conductor to heat up enough to degrade the insulation. This damaged insulation may expose the conductor to other conductors, metallic boxes or conduit, or people. Overload. An overload is a situation where equipment operates beyond the rated ampacity of that equipment or the conductors within the circuit. This type of overcurrent may occur when a motor experiences a large load and draws excessive current for more than a short duration. The overload could also be caused by excessive utilization equipment. See Figure 8-1. This is a common occurrence during the holidays. Homeowners frequently use outlet adapters to plug multiple decorations into a single outlet. The total amperage requirement for all of these devices may exceed the capability of the circuit. Short circuit. A short circuit is an overcurrent caused by the connection of an ungrounded conductor. A short circuit is an overcurrent caused by the connection of an ungrounded conductor to a grounded conductor, or the connection of two ungrounded conductors that have a potential difference between them. A potential difference occurs when two circuits have differing voltages. The first type of short circuit is more likely in a residential installation. Ground fault. A ground fault occurs when an ungrounded conductor touches a grounded raceway, box, fitting, or equipment ground conductor. If an energized terminal on a light switch touches the metal box, the ground fault will occur and trip the OCPD. Without the OCPD, a large flow of electricity will cause the conductors to heat up to a dangerous temperature. Protective devices. Overcurrent protective devices include fuses and circuit breakers, see Figure 8-2. Both are manufactured in various shapes and sizes, but all are designed to stop flow of current should it exceed the safe limit. All fuses and breakers are rated in amperes. The rating must not be greater than the overall capacity of the circuit being protected. Never replace fuses or breakers with protective devices of a higher amperage rating than the one intended for that circuit. If you do, you defeat the purpose of the protection device, violate the codes, and create a fire and shock hazard. Fuses. A fuse is a highly reliable and safe overcurrent device. It consists of a resistance-sensitive link encapsulated in a tube. The ends of the fuse are connected to contact terminals of the conductor. The link has very low resistance. If high current occurs, the link melts and opens the circuit. Two general types of fuses are available, plug and cartridge. Within these two types, the fuses can be further classified as the following: single element or dual element, fast acting or time delay, renewable or non-renewable. Single element fuses have a single element or more links. Single element fuses have a single element of one or more links that quickly melts in response to an overcurrent. The link melts in approximately 3 seconds at a 200% overload current, and usually within thousandths of a second of a within thousandths of a second, less than a half cycle of alternating current for short circuits and ground faults. Since these fuses act rapidly, they're only used in circuits with no transient surge currents or temporary overloads. See figure 8-3, which illustrates a fuse melting and opening a circuit. A dual element fuse. A dual element fuse has two elements arranged in series. One element is similar to the element in a single element fuse and performs the same function. The other element is designed to allow for low-level overloads of about 5 times the ampere rating for over 10 seconds. This type of fuse is particularly useful in protecting a circuit where temporary surges are normal. A dual element fuse is shown in figure 8-4. These fuses are marked with a D. A time delay feature is inherent in dual element fuses. However, not all time delay fuses are dual element. The main feature of time delay fuses, regardless of the number of elements, is that they allow for momentary overloads. A current limiting fuse quickly opens the circuit when a specified overcurrent is reached. These fuses clear the circuit of current in a fraction of a second. Plug fuses. Plug fuses are available in two varieties, Edison base and Type S, figure 8-5. Plug fuses have a maximum rating of 30 amps. Fuses rated as 15 amps or less have a hexagonal window, while higher rated fuses have a circular window, figure 8-6. Plug fuses are limited by the following voltage restrictions: a maximum of 125 volts between conductors, a maximum of 150 volts between ungrounded conductors, and the ground in grounded neutral systems. Edison-based fuses are interchangeable. Fuses of greater current rating can be used in circuits of lesser capacities. This potentially dangerous oversizing problem is eliminated by using a Type S fuse, which uses a screw shell adapter. The Type S fuses must be used on all new installations and for replacement installations. There are 3 classifications of Type S fuses with specific adapters based on the ampere ratings: 0 to 15 amps, 16 to 20 amps, and 21 to 30 amps. Caution: the Edison-based plug fuses. The Edison-based plug fuses have no inherent limit to the use of higher ampacities. For example, nothing prevents a 30 amp fuse from being installed in a 50 amp circuit. Using a fuse with an ampere rating higher than that of the circuit is a fire hazard. Cartridge fuses. Cartridge fuses are used in fuse systems over 120 volts or 30 amps. There are 2 types of cartridge fuse connections: ferrule type and knife blade type. Underwriters Laboratories classifies different types of cartridge fuses. Most types have unique dimensions. This prevents one class from being replaced by another class in a circuit. Some of the most common types include the following: Class H. These fuses can be renewable or non-renewable. The non-renewable types can be time delay. They have a low interrupting rating of only 10,000 amperes and are not current limiting. The low interrupting rating restricts their use in new construction. Class J fuses are non-renewable and current limiting with an interrupting rating of 200,000 amperes. They are smaller than Class H fuses and are not interchangeable with any other class. They are rated for 600 volts and up to 600 amperes. These fuses have no time delay. A cube style of Class J fuses are also available. See figure 8-8. Just as an interlude, when they talk about 10,000 amperes and 200,000 amperes, that is for interrupting rating, sometimes called short circuit rating. Basically, that is the maximum amount of amperes that the fuse will open if it happened to go through the fuse, which is very rare and unlikely, but however, that is the rating, the amount of amperes that the fuse is physically able to break, not necessarily the protection provided for the circuit, which is much lower than that. It should be 15, 20, 30 amp. Class R, these are non-renewable current limiting fuses with an interrupting rating of 200,000 amperes. These fuses have a rejection feature, so no other type of fuse can be installed in the same fuse holder. They may be used as replacements for Class H fuses and rated for 250 volts and 600 volts and up to 600 amperes. Class T, a non-renewable current limiting fuse with an interrupting rating of 200,000 amperes. There is no time delay with Class T fuses. They are not interchangeable with any other type of fuse and are rated at 300 volts and 600 volts and up to 1200 amperes. Procedure for finding an overcurrent source. Before installing a new fuse, there are some steps that should be taken. For this, see figure 8-9. Examine the fuse's window. A clouded window indicates that there was a short circuit or a ground fault. Either condition causes the conductor to rapidly vaporize and overload. An overload will melt the conductor at a much slower rate. You should see a clearer window and less damage to the conductor. 2. Look for the source of the overcurrent condition. If you suspect a short circuit or ground fault, examine the switches and receptacles on that circuit. You may see a black charred area if the short occurred at a device. 3. If the fuse indicates an overload, look for outlets with multiple appliances, overworked motors, or plugged-in machines with a ampacity higher than the circuit's ampacity. If the first condition is the cause, place the higher wattage appliances on separate circuits. Any overworked motors, especially furnace blower motors, may need to be repaired or replaced. Machines with excessive ampacity should be easy to find. Breakers. A circuit breaker is defined in the NEC Article 100 as a device designed to open and close a circuit by non-automatic means and to open the circuit automatically on a predetermined overcurrent without injury to itself when properly applied within its rating. See figure 8-10. Circuit breaker types. A single pole breaker serves a 120 volt circuit. A double pole breaker serves a 240 volt circuit. Typically, these breakers are plugged or bolted into the service panel and connected to the ungrounded wire of the particular circuit they are to protect. The neutral conductor of each circuit is not connected to the breaker, but fastens directly to the neutral grounded bus bar. The amperage rating of each circuit breaker must be matched to the circuit it protects. Information regarding finding the circuit's ampacity is found in Chapter 5, Conductors. Protective device. Protective devices, fuses, or circuit breakers must be adequate to withstand overcurrents, particularly those created by short circuits. Each device has an interrupting rating, which is the maximum amount of current that the OCPD will reliably function. The interrupting ratings of most circuit breakers range from 10,000 to 20,000 amps. Fuse ratings are generally around 200,000 amps. See figure 8-11. Naturally, this is much larger than the normal current rating of the fuse or breaker. The normal rating in the current is the current the OCPD is designed to carry under normal operating conditions. All overcurrent protected devices are labeled as to their normal current and their maximum or interrupting rating. Guides for properly sizing fuses are found in the Article 240 of the NEC. Again, as an interlude, I cannot stress enough to get a copy 2011 or later of the NEC for review and study of this material. Reference it very often. Every time we talk about articles and tables, go ahead and refer that instance to the NEC 2011 or later. The later the better. Some of the page numbers, article numbers may change slightly, but for the most part, they maintain a very similar and consistent material and meaning. So go ahead and refer that as much as possible. Review questions. Number 1, true or false, an overload and a short circuit are the same thing. That is false. A short is contact of grounded and ungrounded conductors, and an overload is a resistance higher than the circuit amperage. Two, the two types of OCPDs, that's overcurrent protection devices, you may find in a residential installation are blank and blank fill-in. That would be fuses and circuit breakers. Number 3, true or false, a clouded window in a blown fuse indicates that there was a short circuit or a ground fault. And that is true. Number 4, a single pole circuit breaker serves a blank volt circuit. That is a 120 volt circuit. Number 4, true or false, the amperage interrupting rating of an OCPD is the amperage that will cause it to open the circuit. That is true. Correction, that is false. The amperage interrupting rating of an OCPD will cause it to open. However, it is not the only rating that will cause it to open. A much lower rating will cause it to open, and that is the normal rating of the circuit, which could be 15 amp, 20 amp, 30 amp, 40 amp. The interrupting rating of the OCPD is the maximum amount of amps or amperage that the fuse or circuit breaker will physically be able to open. Any more than that, any more amperage or load or resistance than the interrupting rating of the OCPD will pass right through. In other words, the OCPD will not be able to open anything more than the interrupting rating of the OCPD. So you have to know the difference between the OCPD interrupting rating, which is the much higher rating 10,000, 20,000, 200,000 amps, and the normal rating of the OCPD, the normal amperage rating, which is usually 15 amp, 20 amp, 30 amp, 40 amp, much lower. That's the rating, the amperage that the circuit breaker will open under normal operating conditions. You have to know the difference between the two. And for that, you have to look at the Article 240 of the NEC to find exactly which rating you will need for a certain circuit. Those may vary very dramatically. Know the code? Question 1. Section 240.24 E prevents the installation of OCPDs in blank fill-in, that is bathrooms, according to the 2011 NEC, page 70-95. And again, I recommend that you read chapters 1 and 2, at least for now, of the NEC. Chapters 1 and 2 are a wealth of information when it comes to understanding the NEC. So read chapter 1 and 2 from beginning to end. Question 2. Section 240.51 covers blank fuses. Fill in the blank. That would be Edison base fuses. And question 3. Which section of the NEC specifies that circuit breakers used as switches have markings of SWD or HID? And that would be section 240.83D of the 2011 NEC. It may be slightly different on later copies. That brings us to the end of the chapter, chapter 8, Overcurrent Protection. Thank you for listening. Good luck with the rest of your studies. Goodbye.